All right, hey everybody, happy Monday. Apologize for the delay in getting started there. Had to do a refill of the water bottle and all that stuff, but happy Monday. Hope y'all are having a great week so far. Hope you had a fantastic weekend. I'm excited to be back at it here on a Monday stream, and we're going to continue working on a number of different things, but primarily we're going to work on the Emotion Mesh project, which I started last week. And have some stream notes for that. Those are up and available in my GitHub repo for the streams. So let me pull that open right now. There it is. Share that here. But that is the info. Let's see, and what we did last week primarily. We'll open up the doc for that. So we started working on this Emotion Mesh project. We're going to continue working on that today after I do a little bit of a show and tell. So let's go through that here very quickly. So show and tell. Let me turn on my desk camera for this. And we'll go into the big desk camera mode. Because I have a couple of different things to show off this morning. A couple of different new pieces of hardware that I acquired last week that are kind of fun, and we'll work on some of those in the future. One of these is the Avnet Brainium. And this is actually a cool little thing, but this is basically an edge ML AI ML module. There's some cool docs on this, but I'm actually looking forward to playing with this thing a little bit. It's basically just a USB connected module with a Wi-Fi chip inside of it. It's not really, there's Bluetooth support, there's a couple of sensors in there, some decent docs online. So I'm gonna mess with this online to actually see what it can do in terms of edge-based processing and things like that. It says in here, it actually has, in terms of what's on it, and I have to look at it for a second. Temperature and humidity, there's an ambient light sensor, proximity sensor, accelerometer, gyrometer, magnometer, all the ohmmeters, pressure sensor, microphone, all of that in this little package right here. So that should be kind of fun to mess with. So I'm gonna spend some time with that over the course of the week. Over the course of the next couple of weeks. So if you're seeing this stream for the first time, or you haven't been here in a while, a lot of what I've been working on lately is edge-based machine learning and intelligence on microcontrollers specifically, but also single board computers. So sort of messing with a little bit of both of those. So that actually leads me to the other thing. This is not specifically an ML board or device, but this is actually the STM32F Discovery Kit. The reason why I got this kit is because it has a touch screen on it. It is an ARM Cortex M4, I believe. Let me see, double check here. Yeah, it's an ARM Cortex M4 core with 1.5 megs of flash, 320K of SRAM. Pretty powerful little microcontroller. But one of the reasons why I got it is because it actually will run microtensor. So microtensor is a port, not a port, but a adaptation of the TensorFlow library by the folks in ARM. And so this uses an ARM-based chipset, and it can actually run some basic TensorFlow or microtensor demos on it. One of the demos in particular is kind of a cool one. It can actually run the MNIST character recognition database based on the touch, or model based on the touchscreen. So you can use your finger to draw a character on the touchscreen and then run inference against that drawing directly on the board and get a pretty reliable result. So I am going to play with that on this thing, which would be kind of neat. Another reason why I am doing that, or want to do that, is because I also want to port that exact same demo over to the Particle. So actually over to the Particle Argon. Particle's new 3rd generation devices are beefy enough and powerful enough based on a similar ARM Cortex M4 chipset They're powerful enough that they could actually run these same demos. Just need to do a little bit of porting of libraries in order to get that working. So that is something that I want to work on over the course of the next couple of weeks. All right, let me move these folks out of the way. And the next thing that I want to show off very briefly, move these over here, is a 12-volt step-up regulator from Pololu. I never know how to pronounce their name. But this little board here is sometimes referred to as a boost converter or a buck converter. But basically what this will do is there's two different varieties of these kinds of converters, usually step up or step down. This is a step up converter. What that means is it can take a low voltage and deliver a higher voltage out the other side. So this will take any lower voltage, in my case a 3.7 volt input, and deliver a 12 volt output the other side. And that will actually come in quite handy for the button box for the Emotion Mesh project that we've been working on, because this is done. The actual button box itself is complete. Let me screen up here a little bit. So the box is done. I have the, let me get this sorry, incorrect. So these two buttons here, these switches, are basically controlled by this little LED, not controlled, but there's an LED piece of this, there's a little thing that pops down, and then there's an LED piece of this as well. And the LED actually takes a 12 volt. You can light it with less than 12 volts, but 12 volts is sort of a better voltage to give this thing in order to really, really light it up. So that's one of the things that we're gonna actually work on in here as well. But this is pretty cool. The button box is actually done. So I assembled this box this weekend. It's gonna have a hole in the back for the cables as they come dropping off. Hole in the back for the cables. Open front, it's actually gonna be closed. I have the front panel for this, but it's gonna be it's gonna be attached with a magnet or with magnets around the side, magnet latches. And then the boards will actually be here on the inside of the box. So that's pretty cool. So we're actually gonna spend some time with this today, start messing with this, building it out, get that in the right place. And actually creating a connection between the devices. That's one of the things that I have on my list today, is to start messing with some of that stuff. Hey, .Commie, happy Monday. Hope you are doing well. I am just getting started, but it is good to see you. Hey, Frackberg. No streaming while you're at lunch. Well, I can't help it. Hey, James. You know, the good news is, I'm excited to see you guys. We're 10 minutes in, and it's been kind of lonely so far. I've just been talking to myself, which I'm happy to do. I'm more than happy to do. Yes, James, I did get a haircut. I did get a haircut. I figured I needed to look respectable for the last piece of news that I was going to share here in a little bit. But yeah, so the box is done. I got the buttons on there, and we're going to actually, I don't know if we're going to start wiring these up today, because there's some pieces I want to get done first to actually get the argon connected to those directly, or connected to the Google Coral board. So we may actually mess with that one a little bit more first today. I don't know how long that's going to take, but we will actually get this wired up pretty soon. So let me go back over. Frank, I know I do too, and I do when you know, I talk to myself a lot when I'm not streaming, so it works out pretty well. And thanks, James, I appreciate that. I'm really excited with the way that the box turned out. You know, it was a multi-step process over the course of the weekend. Kids helped me out a little bit, and I said this a minute ago, but basically right now the front is open. So I have some basically magnetic latches that I'm going to use to put the front panel on, and then the back panel actually has a hole in it where the cables will come out. But the front panel will be able to come off, so I can leave it off so you can actually see the boards on the inside if I want to do that, as opposed to enclosing it completely, because that might be kind of fun for folks. So yeah, well, cool. We'll mess around. And it's a wood box. I figured, I mean, it gives me an excuse to use my power tools. So I took some time to actually build a wooden box over the weekend. It's a wood box. I would likely just use an Amazon box. Well, yeah, here's the thing, Frackberg. I would have done the exact same thing, except I'm taking this thing with me out to Oslo, and people are going to be like pounding on it during the conference, and so I wanted it to hold up. So I mean, this is a pine. This is basically an inch thick pine board. So I figured that would work. You know, I figured it'll hopefully hold up. Not only the trip out to Norway, but also all of the abuse that it's going to take, and the abuse it's going to take from me when I'm actually going through testing. James said, I bought a chunk of oak I assume you mean oak to CNC for a particle powered alarm clock. That's awesome. What's your CNC? What kind of mill do you have? Hey, Hugo Doll, how are you? Happy Monday. Hope you're doing well. Oh, you know, flying with homemade electronics. I do that all the time. It's part of the job. So I've gotten used to it by now. And frankly, I have never had an issue. In fact, I could tell you some stories that might actually make you a little concerned with the state of the capabilities of TSA and international airline security. But I won't get into any of that today. But yeah, I fly that kind of stuff all the time. Hugo Doll, I've heard a rumor that they have some lumber in Norway. They do, but I needed to have this built before I went out there in a month. But you're right, they do. They have some good lumber in Norway, from what I hear. And I'm doing well. And I think it seems like everybody else is doing well. We're just kind of taking our time getting started this morning, which is fine. That's how I like to do it, especially on a Monday. Oh, Frackberg, you work for a local airport. Okay. Well, then, yes, I presume that nothing would surprise you at this point for sure. So, all right. So we walked through, and for those of you that came late, I will show these off again very briefly because it was just me for the first couple of minutes. But I have a few other devices, new devices that I showed off earlier. One is called this Avnet Brainium, which is another one of those edge machine learning AI boards that I've been collecting lately to test out and see how they work. So this one should be kind of fun to mess with. And it's got some cloud-based tools and things like that. And then the other piece, and I am super excited about this, is the STM32 Discovery board. This board is a stock sort of buy it on DigiKey microcontroller-based Discovery microcontroller eval board. But what's unique about this is it actually has a built-in touchscreen, and it has some good docs on running microtensor, which is an open source library from the folks at ARM for actually running TensorFlow models on microcontrollers. And one of the demos that they have built actually uses the touchscreen on this board to run the MNIST digit recognition demo, to where you can actually use your finger to draw a character on the touchscreen, and it will run inference on this ARM Cortex-M4 device to detect what character you drew on the screen. And it has a relatively impressive confidence considering that you're running on a constrained device. So I'm excited about this. Part of the reason why I got this is because not only to run the demo, but I want to port that demo. I want to port uTensor and potentially even TensorFlow Lite Micro over to the Argonne. So the Argonne is also an ARM Cortex-M4 device, and I think it would be really cool to actually do some microcontroller-based machine learning, not just single-board computer-based machine learning stuff. So we're going to spend some time messing with that on stream as well, because that's going to be part of my talk in Norway in a couple of weeks. All right. You would be horrified to know how many parts fall off commercial. Don't tell me, Frackberg. I'm not traveling soon, but I will, in a couple of weeks. I don't want to hear about it. Hugo Doll, for anyone who isn't into woodwork or tooling, if you need various wood containers, craft stores usually carry something that can be decorated. Yeah, absolutely, Hugo Doll, you're absolutely right. If you don't want to build your own, there are definitely some good things out there. And Frackberg, anyone that isn't into woodwork should start, right? Hey, it's not for everybody. I get it. I totally do. James gonna make some dinner. Oh, no problem. Thanks for hanging out, James. Enjoy your dinner. Hopefully you're able to just, hang out and listen for the next little bit. Hugo Doll, I'm into it, just don't have the tooling, the space, or the time. And I totally get that as well. I don't have as much time as I wish I did to work on this kind of stuff, so to do the woodworking side of things. But I figured this would be a nice excuse for me to build something a little bit more complete here. So the last thing I wanted to share is the first thing on my list, because this was kind of a fun little milestone for me, and it's a personal news thing. It's a good personal news thing, but for those of you that I interact with on Twitter, you may be aware that I actually, let me see if I can pull this individual tweet up. I'll wait just a hold on. I might as well just go to my Twitter account. But I have been training in Taekwondo for the last 3 years, just under 3 years. And so the personal news that I wanted to share today just with y'all, because it's kind of fun and a little feather in my cap, is that I actually, I got my black belt in Taekwondo on Saturday. So I tested for it. That's me, the guy on the left there, wearing that black belt. It was pretty fun. So I actually went through that test on Saturday. I've been training for almost 3 years, like I said. So that was a fun little milestone. My oldest kid also does Taekwondo, my 10-year-old. He's going to be testing in November, so I'm super excited about that. But wanted to share that with y'all because that was a fun little, that's been a big goal for me, and I've spent a ton of time training over the course of the last 3 years, and I'll continue doing it, but just wanted to share that with y'all. So I appreciate that. I appreciate the congrats, y'all. Hugo Doll and Frackberg and .com. Thank y'all so much. And that's awesome. By the way, I could just be called Hugo. Okay, cool. Hugo, I got you. I didn't know if you... So I need to have that same conversation with Michael Jolly, because I don't know if Michael Jolly prefers to be called the Michael Jolly or just Michael Jolly. If he comes on today, I'm going to refer to him as the Michael Jolly, to be just like super redundant about it. But Hugo, I'll definitely keep that in mind. And yeah, thank y'all so much for the congrats. I appreciate that. So that's a good way to transition to the next thing. So Emotion Mesh, we started this project last week, and the crux of the project is that this is a set of demos that I am working on and plan to build to actually run edge-based machine learning and IoT with Particle 3rd generation devices, so the Argon, the Xenon, and the Google Coral dev board, which contains an edge. It's a single board. The Coral is a single board computer that can actually do edge-based machine learning. And it has what Google refers to as a TensorFlow processing unit, so it uses TPUs for inference, not CPUs like a traditional computer or even GPUs. A lot of newer devices will use GPU-based processing because it's far more parallel than using a CPU. Google has their own ASICs, custom circuits called TPUs, that can handle inference in sort of their own architecture, which is really fascinating. And so what I wanted to do was actually build a project that uses this box that I've just built that's on the desk. And the box will have inside of it a couple of different boards. So let me actually go into the main project here and open up this board. Give me just a second, y'all. Oh wait. Do I have the main image on here? Maybe I don't. That's all right. Maybe it's under assets. There we go. This is a larger version of this image. There we go. So there's a few things that will effectively take place in this image. or in this project, is that there is the box with a couple of buttons on it. There's the Google Coral board that's going to be connected to an HDMI monitor. There will be a USB camera connected to it as well for face tracking and motion detection. And then there is also going to be a particle argon that serves as a gateway in a mesh network. And that device is going to be UART, basically serial connected to the Google Coral board as well, so that it can trigger face tracking demos, it can trigger emotion detection, all that kind of stuff. The Coral will have some pre-trained models on it to do face tracking and to do emotion detection. There will also be some cloud-based emotion detection using the Azure Cognitive Services Face API, and that was one of the things that we set up last week. So we can look at that very briefly. And then there's going to be some other pieces around that are going to be particle xenon-based devices or edge devices that will do things like I'll have an ultrasonic distance sensor that triggers the demo, and then a handful of NeoPixel strips that will play animations. An attract animation when it's idle, a processing animation, and then red or green animations based on the results. So the way that it'll work is when you are someone consuming this demo, you'll walk up to where the demo is sitting. In this case, on the show floor somewhere at the NDC conference. And you'll trigger the demo by walking past the ultrasonic distance sensor. It sees you, the demo will start, the screen will come up, and the buttons on the box will light up. And it'll start doing the face tracking piece of the demo with the camera. When you hit the green button, it will capture a photo, and it will do a couple of things. It'll actually do local emotion detection based on a model that I've built. And then it will also do Azure-based emotion detection as sort of a backup or verification step, so we can compare cloud-based ML with the local ML piece as well. And then it'll show you the result on the screen. And then you can hit the button, green button if the guess is right, if the emotion you conveyed is the one that it inferred you did. And then red button if it's wrong. And we'll have the dashboard, or the monitor will also have some a live view of statistics, like how the model is doing, how it's performed over the course of the conference, and all that kind of stuff as well. So those are all the various pieces that we're building, and all of this is actually in the GitHub repo. I think the project command is still active. Yeah, definitely. So there's the GitHub repo for that. Everything that I've done over the course of the last week is in there as of right now. And there's also a description of sort of the various states that I just described and how all those things are meant to work, what the hardware looks like, and then some of the dashboard, what the dashboard will look like, some statistics, things like that. So that's an overview of the project. If you weren't hanging out with us last week to talk about that. And I have a project board for that as well. So what I wanted to do before I get too deep into working on this today was I actually did want to spend some time talking about what we did last Monday, and then I want to talk about what I did off stream over the course of the last couple of days. So what we did last stream was that we set up cloud-based emotion detection with the Azure Cognitive Services Face API. So in my project, in this emotion mesh project, there's really three pieces right now. Let me go back to the GitHub repo. There's an emotion model. This is sort of all of the TensorFlow and Keras work to build the local model for the local detector to use. The local detector is everything that's running on the Google Coral board itself. So the web server to run the webcam, all this kind of stuff, that's all running on the Coral itself. And then there is the cloud detector, which is Azure, basically just uses the Azure stuff. It's still a Python script that does it, but it uses the Azure Cognitive Face API to do some fancy stuff. We'll talk about that. We'll look at that in just a second. So, actually, we'll go ahead and look at that now. The cloud, because this is what we worked on a little bit last time. There is a Python library for this, Cognitive Face. And by the way, a lot of the work that I've been doing here in this project has been Python, which is relatively new for me, but it's been kind of a fun experience. what basically happens with this demo is that you provide an image, you save an image somewhere, and in this case the webcam is capturing it. It opens the image, it actually draws a bounding box around the image, and then it actually performs inference against that as well. So it draws a rectangle given the result from the face API, right? That actually happens right here. Takes the image path, and that gives you back a JSON object that has a whole bunch of information. A bounding box, coordinates for a bounding box for the face. There's an emotion array as well. So there's a few things that happen there. One is it draws a rectangle, then it actually will draw coordinates on the face, and then also will draw the main emotion on the face. And the main emotion comes from this dictionary. It gives you, I think there's like 6 or 7 different emotions that it's looking at, or that it can return to you. And it basically gives you a object that has a percentage confidence that the image has each of those emotions. So you could get something like 30% neutral, 65% angry, 15% happy. Something along those lines. And you take the highest one. Basically, you get the highest one of these, and that's the one that you draw on the screen. So what this ends up looking like in practical, so if I have a source image like this is me smiling at the webcam, if you couldn't tell, it could actually return something like this. Well, here, actually, let me open this one. There we go. So if this was my input image, the output image that I was getting from the Azure SDK is this. That's happiness. Apparently that's happiness. And that was me last Monday. Hey, Robert Tables, happy Monday. Hope you're doing well. Thanks for coming in. We are not just getting started, but 30 minutes in. I've actually gotten to the point of getting to what we covered last Monday. So you're right in time. That was what we did last week, was actually working with the Azure Face API. And all of that stuff is on the Coral board. It works. It's ready to go. So then what I did off stream was a lot of painful work trying to understand Python with WebSockets and protocol buffers. So painful to learn all of these things. And you all should feel very good that I didn't subject any of you to doing any of that on the stream last Monday, because it sucked hard. I got it working. I got it working, and I'll show you some of it in a second. I'm gonna run the demo so that you can actually see what's going on. But it was a slog through the mud, let me tell you right now. So let me actually get onto the board real quick and get into my emotion mesh demo. And let's see, do I need to do a poll? Yeah, let's do a poll just in case. Which means I'm gonna have to log in. Oh wait, no. Wait, what? Oh, origin. Come on now. Full origin master. Yeah, .commie, I'm not kidding. I mean, it was pretty bad. I was banging my head, and I don't know, and I posted this on Twitter, but I mean, to the point to where like I was editing files that I had never seen before, and then like an hour into hand editing protocol buffer files or protobufs files, I saw a comment at the top of the file that said, this is generated by a tool, do not edit. And I'm like, in Robert Tables terminology, I'm like, heck! Except that's not the word that I said. The last 2 letters were the same. But once I got to that point, I felt a lot better. So it was one of those learning experiences where like you slog through the mud and you feel like, what's that? There's a graph I've seen many times before, like the journey of mastery. I think Kathy Sierra said this a long time ago. The journey towards mastery in a new thing is you're like oh, this is awesome. I'm so good at this. And I'm like, I suck so bad. I'm terrible. I'm awful. I'm the worst person ever. Oh, I think things are working again. You're like, oh, okay, this is cool. I can handle this. That was the experience that I went through. I think this was like Tuesday, Wednesday, Thursday last week, messing with some of this stuff. So it was not a blast, but we're past it, and I'm going to show you what I ended up doing. Because there's some fun stuff that's going on, and I learned a few things about protocol buffers, and they're actually kind of cool. So let's run this demo. If I still have my, oh, come on now. Python. All right, fine. Python 3. Okay, detect server. There we go. That's my local detector. All right, so my server is up. I'm gonna go back over here. Hopefully all right. You may have noticed I did a couple of different things on here. So what's running is actually running on the Coral, the Edge TPU board. In fact, let me go ahead because let me turn the camera back on. James, literally my life at the moment learning a new code base. I hear you, man. And Robert Tables, there's the button box with the black spray paint. And you were right, some of the wood grain does show through, and it is all right. I like the way that it turned out. So we will keep working on that very soonish. Here, and here's what I'm gonna do now. I apologize for the janky cameras. Hi, how's it going? All right, I'm gonna get my Coral board in there, and then I'm gonna get the Argon in here, so we're gonna connect that here in just a moment. And then I'm gonna bring this down closer. So again, sorry for the janky cameras. I just want y'all to get a good enough view of the action. Yeah, thanks, Robert Tables. And hey, the Michael Jolly. How are you, sir? It was so much fun to hang out on your stream yesterday. Your stream, my friend, was very long. I did not make it the whole thing. I apologize. I hope that I didn't leave you hanging with any particle stuff too late. But I had to get dinner on the table for the kiddos and all that fun stuff. So but it was fun. I actually really enjoyed watching, and hopefully I didn't steer you wrong in too many different things yesterday. And I'm so glad to hear that you went that long because you were having fun messing with particle stuff. And thank you for the host, Michael Jolly. I appreciate it. All right, yeah, Robert Tables, it did come out great. I'm really happy with the way the box came out, and hopefully it'll be durable enough to stand up to all the abuse that I'm gonna subject it to. Yeah, okay, come on. Hold on, I'm moving the camera. I'm being very particular right now. That was not correct. Oh, the delay is killing me. Okay. Frackberg, is this the Coral board? This is the Coral board right here. This beautiful little single board computer. Oh, that's timely. The fan just turned on right as I picked it up. Underneath this heatsink and fan is the actual Edge TPU module. It's very small. This is about the size of a Raspberry Pi, maybe slightly larger. But yeah, that's the Coral. And this is what is actually running what you're seeing on my screen here. This is what's actually running here. Which is crazy. It's crazy. I mean, it's giving me 130 frames per second of very reliable face tracking. Right? I mean, look how good that is. It does a very good job. I mean, I can't get over how cool I think that is. I mean, sorry, I'll probably get tired of hearing me talk about this, but anyway. So the server is running. So my first challenge was, I mean, was to take this default demo page and actually to turn it into something a little bit more useful for me. And what I wanted to start with was adding a couple of buttons to it to actually capture an image. Of course, adding a particle logo because, I mean, why wouldn't I? And then adding a title with a non-Comic Sans font. Although I was tempted to just do Comic Sans anyway. So that actually started my journey of diving into the source for this thing. So let's actually look through that now. So inside the local detector part of the project is everything, a bunch of Python files that actually run these demos. If you recall, when I first ran these demos, what I was doing in the early parts of this a couple of weeks ago, excuse me, was running a command, a Python script on the command line that would turn on the server and pass in a TensorFlow Lite file with either face tracking or motion detection and do some other things. I hard coded some of that stuff so that I don't have to pass it in every time because I know I know what I'm using it for locally. And then the other piece was to sort of figure out, okay, when the server is started and it's this is what was run before, was this detect server. That imports something from a file called apps or a module, and then that imports some other things. And so it sort of led me down this path of understanding everything that's happening here with creating a camera, using this camera object because it doesn't use typical Python or Raspberry Pi libraries for camera detection like OpenCV or anything like that. Google basically implemented their own camera object that uses GStreamer. So I had to learn a lot of that stuff over the course of the last week. But when the rubber met the road, what I realized last week, and I think we did this last Monday on stream, was that there was a command inside of here, inside of the GStreamer library, which is effectively what runs this camera object in the background. That was empty, but I basically added a command that if you were in the command line, right, if you were right here, that I could hit S and it would capture an image. And this is actually under me right now, so let me bring this higher. Right, so I hit S and this actually captures an image from the camera. Right, and if I, oh, I gotta go to, oh. I turned the music down too much for myself. And so if I capture an image, should be where it is. No, that was from last week. Where'd it go? Oh, there they are now. Okay. Sorry, it took a second to reach. So, all right, so this 1996 was an image that was just captured on the device. Right, so that's me just now talking, wasn't looking at the camera. So we figured out that this was actually able to capture an image using GStreamer. And what would happen further down here, and again, if I'm over explaining, it's because I'm trying to remind myself how all this Python magic works because I don't understand it. What happens here is originally what was in here originally was just this one if command equals save frame, then save frame equals true. And then what would happen is every single time this would run on new sample is where this runs. So this is basically a callback. The sample is every time the server samples a new frame, if the command S has been hit, capture that image and capture that sample as an image and save it off. Right? That's what's ultimately happening here. And where that happens is higher up. I'll show y'all. Where that happens is right here, is on this save frame. So what was happening is just like you saw, it saves the frame with nothing else, without putting anything on it. You can say you want to save an overlay. I didn't. And that's just what saves out the raw image. So I knew, and that's sort of where we got on the stream last time, was we figured out how to get this demo running, and there's a way to capture an image from the stream in the background. So where I spent a lot of time over the last couple, or over the several days last week, was then figuring out, all right, how do I, from this page, not from the command line, I know that I can hit S when I'm running in the command line, interactive, and capture a frame. How can I allow a frame to be captured from this web page? Because if I can figure that piece out, then it'll be really easy to trigger it via a UART connection between the two devices, which is my ultimate goal. If you'll remember from here, not there, that the ultimate goal is actually to have hitting this green button on the Argon tell the Google Coral to capture an image and trigger the whole process. So that's going to happen on a microcontroller, not on the command line on the device itself. So doing that via the web page for me was sort of like step one to understand what's happening in this whole process. So this index.html file is inside of a folder on the Coral under streaming. And this is all stuff that was part of their canned demos that I went and modified. Added the particle logo, and then I added the buttons. And basically what I did was I installed Vue.js because I like Vue. It's what I've been using lately. And I installed Vuefy, the Vue framework. And then I basically just created a very simple Vue app that with two buttons. Image, capture image, and reset. The reset button calls a function. This reset doesn't do anything yet, sorry. The capture image button calls a function on the background. Yeah, James, I'm a big fan. I like Vue a lot. I spent some time doing Angular. I spent a lot of time over the last few years doing React. I've been a big fan of Vue lately. It's simple. It works well for me. I know there's a lot of other options. And I mean, I've been doing web stuff for a long time, so I don't mind learning something new every once in a while. Okay. So there was this library that was already in here, ws_client.js. And this is what was actually communicating back with the server. So this was sort of the next piece that I had to understand. And hopefully y'all find this interesting. I apologize if, like, I haven't written any code yet today, but I don't want to skip over what I did off stream for those of y'all that were paying attention last Monday. So tell me to shut up if you want me to just move on and make with the codes. Inside of here was most of this stuff, right? Creating the player with a decoder that actually shows the video and all this stuff. And I added and then there was this onload. And this is where I started my journey into protocol buffers, which I'm not going to cover completely or explain totally today. But in the onload, this basically sets up a WebSocket connection between the Coral board and itself that handles communication between client and server. This index.html page basically runs only with WebSocket communication to the backend. Right? So that is at this location /stream. So this IP address /stream is actually where the WebSocket server is hosted. It sends messages, receives messages, all that kind of stuff. And so I'm like, all right, well, I guess I have to do the same thing. I'll just do WebSockets. So my capture frame function, this is what I added, effectively does the same thing. It creates a new socket at this location and sends a message. It sends a message with, and I'll get to this piece in just a second. It sends a different message to the backend than the streaming server does. Because what's happening right now is that there's socket communication going on here. Watch. Let me refresh the page. Whenever I refresh the page, the socket, the whole process repeats. Right? The socket gets connected, the server stops, it restarts itself, the device connects to the camera, it starts actually capturing frames. Right? And all this is happening over and over again. What I effectively wanted to do on this side was to allow this capture image button to do something very similar for me. So what happens in WS Client is that I'm creating a new image, or I'm creating a new object, and you'll see what happens here. This is really the only piece that matters. I'll oversimplify. Is I'm creating this message here. This is basically a protocol buffer or protobuf message. The protocol buffer message is a very lightweight payload. Protocol buffers were created by Google as a lighter alternative to XML for communication. They require a compiler to generate messages, but once you and some SDKs to interpret messages, but they're relatively flexible. They're forward compatible, so you can make changes to them without breaking previous consumers or clients of the protocol buffers, which is kind of cool. And so in this case, when I load the screen, what I am doing is saying, okay, stream control enabled. Cool. And then what happens on the other side is that there's the server Python file. Server.py is my server. Is actually the web server on the back end. This is what's waiting for WebSocket messages on the other side. So what that looks like is, let me go to the right place here, because there's a whole lot of stuff in here. And he scrolls, and he scrolls some more, and he scrolls some more, and he scrolls some more. See if I can find the right place. Is it under server? Synthwave really is nice, isn't it, Michael Jolly? I love it. I really do like it. Okay, there we go. So what happens is that every time a message comes in, the server decodes it by looking for a command. It's basically like parsing JSON. The way that I would oversimplify this is all of this stuff here on the Python server side and all this protobuffer stuff is just a different way of parsing communication between client and server in a different sort of syntax. It has more moving parts. Protocol buffers have more moving parts to them than JSON. I don't know that I like them better. I still prefer using JSON when it comes to web. I think I can see the advantage of doing this in the embedded world. So protocol buffers are pretty popular in the embedded world because they're even smaller than JSON objects. Definitely smaller than XML, so that could be kind of interesting. But basically all that's happening between these two messages is that I am sending, and I'll show you actually what the, and again, I feel like I'm a little bit scattered today, so please forgive me. This is what the message sort of looks like from when I pass in stream control. I'm basically saying, okay, start the web server, start the webcam, start streaming my face, and start streaming whatever you see and draw the frame over it. So what I did was I added another, the Magna Carta is smaller than the simplest XML. You're right, Hugo. That's very good. You're right. That's very true. Hey, Grogard, happy Monday. Happy Monday to you. Did you get to, Grogard, did you get to spend any time at Bay Area Maker Faire this weekend? Looked like it was a good time. Sorry I wasn't there. It looked like it was fun. So I added another protocol buffer message called frame capture, which does the same thing. Not the same thing. It was the way to differentiate a command on the back end. Oh, you didn't make it out that way? Oh, no worries. No worries. So what I wanted to say basically is anytime that I created, and then these messages get captured up into this parent message called server bound. And that server bound message either has a stream control message to say start the stream, or a frame capture to say capture a frame. That is an oversimplification, but the way that that works on the JavaScript side is that I basically send a message on the WebSocket that says start the stream, and that's what's happening right here now. And then in this other new function that I created called frame capture, I send a message that says frame capture, don't capture an overlay, so that I can then hit this button. And that's what gets sent when I hit this button. And that took me a day or two to actually figure out, once I actually got that part working. Once I actually got that working, what I was able to do is anytime a message came in, I'm able to say, okay, either handle stream control or handle frame capture, right? And when you handle the frame capture, what I'm saying at that point is send a command to the server to capture the frame, and then the fun begins. And this is actually where I've got most of the new code here. And this is what's happening here now. So when I want to capture a frame, what I'm doing is I'm calling on the camera object a capture frame method. And this is something new that I added. So let me, where's capture frame? So capture frame basically just sets a global, and again, Python noob, no idea what I'm doing other than just getting things working and not too concerned about whether or not it's correct or the right way, is I'm setting a global and then sleeping for a moment so that my GStreamer object, oh, thanks Grogard for the 4-month resub. I appreciate that. I love it. Thank you very much. It's very nice. I know time does fly. It's crazy. I am once again super bummed that Supply Frames Teardown is when I'm going to be in Oslo. So I'm going to miss it and miss getting to see the giant board up close. But I will ask our mutual friend David Cheltema to take pictures of it so that I can see close-ups. And I wish you luck with that next month, because it's going to be really fun. Really fun to see that project come together. So then what happens is GStream. All right. But yeah, thanks again, Grogard. I really, really appreciate having your support over the last 4 months. It's been a lot of fun doing this. So here we go. And this, remember what I said earlier, if I would hit the S button, or S button. If I hit S in the command line, that it would capture a frame. So basically this does the same thing. So this is a way for me to wire in or hack in the button press on the web page to do the exact same thing that I was doing when I hit the S key on the keyboard. So what now happens at this point is I'm capturing a frame, and the path to that frame gets captured and it gets logged. And then what I'm doing is a couple of things with it. I'm moving it, and this is where I actually made myself comments so that I would know what the heck I'm talking about later. Is I copied the photo to a folder for the cloud detector, and then I moved the folder into a local detector image. So I don't keep it, I basically copy one version of it and then move it elsewhere into the local detector. Grogard, I think I might be able to help you out with seeing a giant board up close real soon. That would make me so happy. Oh my gosh, that would make me so happy. That would be so awesome. Okay. I'm about to take a bio break because once I get done explaining all of this, I'm gonna take a quick bio break, and then we'll actually do it live, write some real code that does some things. But I'm nearly there. I'm nearly sort of getting up to speed on what I did over the course of the last couple of days. So I move the images, and then I call the cloud detector, and the perform cloud detection function I showed earlier, that's actually here in detect face, in the detect face module. And this is the module I showed up earlier. This is what we did last week, where we can take an input file and actually draw the bounding box using the Azure Cognitive Services Face API. So I got that piece working. That piece is great. It works, it does its thing, it's awesome. So I do the facial detection on the, and I'm about to demo this. So I'm explaining all this. I'm actually show you all that it works. Excuse me. I perform cloud detection, and then there's some pieces here that I haven't added yet, adding the local detection, because that's the stuff I have not done yet. And then call back in the client, and then show the image. I haven't done that either. But then what I did in order to sort of save myself some space is I plugged an SD card into the Coral board, and I moved the files onto the Coral, onto the SD card. So I'll actually have sort of the historical photos there over time. They won't be taking up space actually on the Coral itself, they'll be on the SD card. So let's demo this really quickly, and you'll see things sort of log across. Let's actually see what happens here. So I'm gonna make a face. I'm gonna do, let's see what this, let's see. So let's try surprised. Let's try surprised. Or is that gonna be scared? Okay. So you'll see a couple of things in the log here. Captured the frame. And the result that I got back from the cloud detector was surprise, 0.991. So that's what the Azure Cognitive Face API thought. 9.1, so 99% surprised and 0.08% anger. I mean, is there a little bit of anger in every form of surprise, maybe? It would be sort of interesting to determine. So now if I shut the demo down, I'll show you. What was the name of that? 622, right? And if I ls disk1/images, which is my SD card, that is 236.231. 622, is it in there? Yep, 622, okay. So now what I'm gonna do is I'm gonna go over to my machine. I'm gonna open another tab that's actually just local. GrowGuard, have you tried CircuitPython on the Coral? I saw Lady Ada added, oh no, really? Oh, that's awesome. Let me make a note of that. Thank you, GrowGuard, I didn't try that out. Circuit, I have not. May be available on the Coral. Look into it. Robert Tables, that's great. I was surprised by an IRS tax audit years ago. Can confirm was angry. You're probably more than less than 1% angry, I bet. So in this case, the detector was maybe a little wrong. And for my thanks, I want to make sure that I add GrowGuard for the 4-month resub. Very much appreciate that. All right. Where was I? Oh, yes. So now what I'm going to do is I'm going to actually SCP those images over into development. We'll do this. Particle. Yeah. And you'll notice it actually saved. Yeah. It's funny, Michael Jolly. Development particle. Where did I do this? Emotion mesh. And then what do I have here? Let's do cloud detector. Resources. All right, we added it in there because I want to pull this. Show off. I'm going to show you all this image real quick. So cloud detector resources. That's my whole point in doing this. So there's the image. I'm opening it up. All right. So all of that, I will have a faster turn on actually checking these out. But there's my 99% surprised, 1% angry photo. So all that's working. This is all actually executing from the Coral board. And I'm gonna close that. That's horrifying. Triggered by clicking this capture image button. And now that I'm describing it, it's like, oh yeah, okay, that wasn't so hard. Let me tell y'all. I don't even want to, it was so hard. It was so much work. But we're there, which means it's actually now time to move on to the embedded stuff again. So what we're gonna do today is I'm gonna set up this Argon as a new mesh network. And then we are going to set up some firmware projects. And then we're going to configure some UART communication between these two devices. We're actually going to get that part working. So that is my goal for today. Hopefully that goes well. We'll mess with some serial stuff. And then maybe even get the arcade buttons wired up as well. Reorder things here a little bit. But that's the plan. That's the plan for the next couple hours. I'm going to take a quick bio break to get a little bit more water, stretch my legs, and I will be back in 2 minutes. .com, you caught me. I don't have the bot on. I forgot the bot. So let me turn it on now. Ah, so undisciplined of me. Let's do that. Stop the bot. You can stop the bot. Yeah. Yeah, so I have not yet deployed the bot. So the bot is just running local. So the song goes in my head. Definitely. All right. Particle. No. What? Maybe .commie it'll work here in a minute. If you are so inclined, .commie, after all that, Chase should work. Maybe. Maybe. But let's actually get, yeah, let's get this Argon set up. My first step. This is not a brand new Argon. It's not new in box. Chase Fuchsia. A little bit of a delay, but it worked. All right, so this Argon, I'm going to put back into listening mode. He's doing some very strange things. Hold on. If you have never seen this, really? I will hold my phone up here. It's upside down. Oh, here. For y'all's benefit, I'll turn it around. And you can see it. I'm going to scan data matrix on my Argon. Come on. This is basically the pairing process for new particle devices. I don't know if that's showing up. Yeah, it's not looking great here. Too bright. And so now what it's doing is updating the device OS on the device. So that'll take a few minutes. And while it does that, let's create a new firmware project. So I'm going to go into the emotion mesh. Grogard, I wish I had more time to play with other hardware, but it's also a good thing because the giant board software is in good shape. That you got priorities, man. You got people expecting a great giant board product, so no worries there. But I get that because even, I mean, my day job, part of my day job is working, or my entire day job is working for particles. So my bias most of the time is working with particle devices, which is fun and they're easy. But I do acquire other devices, not manufactured by Particle, and I wish I had more time to play with those as well. So I totally get it. So in the Emotion Mesh repo, I'm going to create a new branch. And we're going to call it Gateway. Yeah, Gateway. Mesh Gateway. Okay, what? Git? Oh, sorry. Git checkout. I can't get good. Turn off the watt camera. Git, G-I-T, good. Get good. All right. Make directory firmware. It's going to have all the different firmware. And we're going to make another directory. No, we're not going to make another directory. Because we're going to open up another VS Code window, because one can never have too many VS Code windows open at a time. At least not that I've seen. No worries, Robert Tables. Hopefully that work call goes well. And I hope it's not a call that could have been an email. So the device is now asking me. Not that one. Desk camera. If I want to leave the current mesh network. And I do. So let me go back over to this for a second. So I'm going to use this Argon in the mesh network. Next. 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 It's looking for my Wi-Fi. I want to get the camera to actually like not. Pick a network. And secrets. So, yep, the blinky. Oh no. Oh, is this one of those Argons that I bricked on the stream recently? This may be. I think I need to go get a different Argon. So, Grogard, does the Coral have a free UART? If not, do they make it easy? Yeah, they do. There is a free UART, which I'll pull up in the docs in just a few minutes. But yeah, there is one. You spent a lot of time with that on the giant board? I bet. Do you just have you just gonna have a single UART on there, or what? All right, I'm gonna get another Argon. I'll be right back. I got two more, just in case. We'll swap out the antenna. Let's see if this one does. Brick. So I'm going to repeat the process. All right, connected. Using mesh network. Good. This one doesn't need a firmware update. Searching for Wi-Fi networks. So I have it set up right now that you can edit a text file that loads on boot and mucks many different. Oh, that's really nice. Right now you can have the main Linux UART plus one more. Very nice. Okay, so this one's going to be called Emotion Mesh Gateway. That's what I'll call it. Emotion Mesh Gateway. And then the network name is going to be Emotion Mesh because, well, Why not? Now I'm giving the network password. You'll see that my Argon is online. It is happily breathing cyan. And the mesh network is being created. So, back to business here. Nope, not that one. Back to business here. I open up Visual Studio Code, and I'm going to use the Particle Workbench extension to create a new project. That new project is going to be in Emotion Mesh. Put it in firmware. We'll say that's the parent folder, and we're going to call it, let's see. Motion controller. There we go. All right, so that will now create the project in this directory that we just created. The motion controller is in there. Eventually, I will make that a multi-root workspace with all of the different firmware projects, but for now, since we're just working on this one, we'll just start with that. So that adds a project properties file. It adds a source directory. And, okay, so it's this .ino file. I am going to rename this .ino to .cpp because I prefer just C++ files over the .ino default sort of Android.ino files. But that means I will also do the include application.h so that I get all the particle goodness in there. And let me delete this stuff. Do not want the .NET CLI tools. Thank you. We'll fill in all that other stuff later. Cool. So we have, what did I have on my list here? Set up the Argon as a gateway on a new mesh network, set up firmware projects in the Emotion Mesh repo, and let's just go ahead and check that in. I like checking things in even when they're super small because it's fun. So git all right. Hold on. Base firmware. Launch bar, stay up. Okay. Oh, I'm having it's Monday typing fingers. I'm having a hard time with it. Okay. So now it's time for the fun UART stuff. So Grogard, I'm glad you're here because this is where you may actually help me not look like an idiot. Because basically what I'm doing is serial between my Argon to the GPIO pins on the Google Coral board. And so here's the header pinout. There are GPIO pins, so there's basically 3 UARTs on here. The base UART, TX and RX is 8 and 10. Pin 8, pin 10. So what I'm going to do is connect those to TX and RX on the Argon and hopefully do it correctly. And then the way that you work with those on the Python side is using the Python periphery library. I think. So periphery, so I have the periphery docs open here. Periphery actually does have some good examples for GPIO. And this is where, so Grogar, this is actually probably where I could use your input because you would know this stuff better than I would on the Linux side. Is periphery has GPIO support. So Grogar, my understanding here, and I'll copy the docs over, is that these pins, so there's a Raspberry Pi compatible 40-pin header on the Coral, and oh, I see the periphery pins listed here on the side. So that's interesting. But 8 and 10 here, if I count from the top, right? Drop my hoodie. Eight and 10, if I count from the top, are UART 1 and 2, which I should be able to work with. But so the periphery examples use just sort of GPIO input output, but there's also serial. But I'm guessing that assumes that's a straight USB serial connection, right? Like if I do, because like basically what I want to do here is take the TX and RX pins on the Argon. Oh, okay, so Grover, that's, okay, thank you. I didn't express it well, but you answered it. So you can do that to any UART in /dev, right? So once I actually hook these up, I should actually see a dev TTY entry show up on the Coral, right? So if I do on the Coral, right? If I do ls dev TTY, this list should have one more. Or is there, will it have one more? Will there be a new one that shows up? Or will this map to one of these on here already? Right? Probably TTY S0. Oh, S0, 1, 2. Oh, I see dial out. So one of those. So it's just going to be a matter of like, hey, BS Claro, how are you? Happy Monday. So I'm about to actually create a UART connection between a particle Argon and this Google Coral board right here. See if we can get that working. So one of these GrowGuards, it'll just be a matter of like guessing basically. But I would assume, okay, so tell me if I'm wrong on this. My assumption is that one TTY S0 would be the serial, the main serial port, and one would probably be UART 1, UART 2, UART 3 here. I mean, that would be logical, right? Oh my gosh, BS Clara, that's really funny. Somebody in Adam13531's channel said that he had half a meg. No, 0.05 megs. Oh, wow. Those are some old school speeds right there. So let's wire this up real quick. So let me go big on this camera. And I'm going to start with so I'm going to take TX on the Argon, which is here in the bottom, and I'm going to plug in RX, the white cable, RX. So TX on the Argon is going to go into RX on the Coral. And if I orient my mind here correctly, 1, 2, okay. So TX on the Argon, RX on the Coral is 10. So 2, 4, 2, 4, 6, 8, 10. All right, so that means that, oh, yeah. So now RX on the Argon goes into TX on the Coral, which is 8. 2, 4, 6, 8. And if Brandon is able to read things properly, which he might not be, that should be enough. Yeah, Grogart, so TTY is 0 is probably the USB UART, yeah. So BS Claro dial-up, Edge Cell is better than that, right? No kidding. No, that's crazy. I feel bad for that that individual. That's rough stuff. All right, so what we're gonna do on the particle side is I am going to configure yeah, Grogard, okay, cool. So it'd be something like this, serial.serial, dev, TTY, baud rate, timeout, okay, cool. I'll set that up on the Python side here in a second. I'm gonna do serial on the particle side first. So let me pull up the docs on this so that I can remember. Oh, actually, hold on. I have some code for this. I have a project for this I can look at. More in the frame. Particle, xenon, right? Yeah. I have a project where I've done something similar to this before, so I'm gonna steal my code from 6 months ago, 8 months ago, to do this. Grogard, I was literally using PySerial yesterday. Nice. Well, you come to the right place if you're looking to help somebody today. All right. Okay. All right. Give me just a second. I got to figure out where all this is at. Okay, maybe that's it. Oh, it's right here. There we go. So yeah, so I will use a higher baud rate. I think doing something like 11.5.200 is probably a good idea. So the way that this starts on the particle side is I use serial 1, begin, 11.5.200. And I think what I'm gonna do is just for now, every like 10 seconds, I'm just gonna send a serial 1 print. So this is on the read side. I thought I was like sending messages here as well. Oh, there it is. All right, let me just wait for... So we'll do if serial 1 is available, and I'm gonna do a lazy delay here, 10 seconds at the end. And so this works just like using the regular serial output, the serial monitor. It's just the serial 1 dot print. Do a simple print line. So, and I'm going to keep this simple so that I don't have a ton to parse on the other side, actually on the Python side. What I was doing here was just printing characters, just 0 and 1, right? So I'll do a similar thing here for now, basically just to print 1, send that across and make sure the connection is valid. So I am gonna, now that I'm here, I'm gonna flash this to the device. So I'm in Particle Workbench, and let's see. Yep, pick the latest device. This is a Argon. What did I say the device name was? Don't do myself any favors. Oh, James, cool. You got a piezo sensor today? Where did you get it from? Emotion mesh. All right, let's do a cloud flash. Not. eBay. 5-pack for £3. That's fantastic. eBay is great for that kind of stuff. AliExpress as well. I just got a bunch of stuff for AliExpress, and if you're willing to wait an indeterminate amount of time, you can get stuff for super cheap. Thankfully, for the stuff that I needed, I was able to, but yeah, you got to be okay to wait for it. Shipping does take forever. BS Claro, hey James, do you want to share a link to the specific sensor that you got? BS Claro, the, and I'm assuming, James, you got like discs. You got like piezo discs, right? I will show BS Claro. It is something like this. I'll just copy in the Wikipedia page. Why not? Wikipedia is pretty good sometimes. But BS Claro, I've actually used these as like knock or like very rudimentary like knock sensors or motion sensors. Like on my home brewing stuff, I used it to basically trigger a wake up during fermentation. So it actually detects fermentation when it starts. So let me check the... GrowGuard, if you pick ePacket, oh yeah, that's right. If you choose the ePacket option, you can get stuff a lot faster. That's true. Yeah, these are great. So James, the one thing that I will tell you about these discs is that the wires on them are very flimsy. Like they are infinity gauge. I mean, they're just like so stinking thin. So when I use those, when I use that for my Brew Buddy project, I basically, I cut those. I desoldered those wires and I just put new ones on there. Like thicker gauge wires on there. I think I did like 18 gauge or something. or maybe even 22, but anything better, anything is better than what's on those. Oh, and you had 2 that were missing wires? Yeah, that's not surprising. Yeah, BS Clara, exactly. It's pretty cool. They're pretty cool. I like that for the alarm clock. That's a really good idea. And Grogard, sometimes it takes longer, but never really longer than like 2 weeks. Yeah, that's cool. That's really cool. I have to remember to do that next time. Because I ended up, Grogard, I don't know if you saw this, but I ended up getting all the parts for that. What is that thing on Tindy? I got the Snap-on Air Raspberry Pi Zero PCB. I'll show the image for a second. So I got one of these, this $10 PCB. The idea was I wanted to build a little portable Raspberry Pi Zero based like pen tester machine that I could take with me. And this is really cool. It's only 10 bucks, but there's like he did not publish a BOM for this. So I did find somebody on Facebook that had replicated the BOM in an AliExpress wish list. And so I bought everything for it on AliExpress, and it's a bunch of just separate vendors. But you know, getting these keys and the IC that's the keyboard driver, and then you know the LED on the top, and then a few things, the switch, and then there's a whole bunch of junk on the back and all this stuff. So I ended up actually sourcing all that stuff on AliExpress, and it was like 12 different shipments that took anywhere from 2 weeks to a month and a half to show up. But yeah, this guy's fantastic, James. I love his stuff. It's really neat. He's done some LoRa stuff as well. There's like a LoRa pager. Yeah, here's the LoRa pager. So that's pretty neat. Yeah, I like that. That's really neat. All right, I'm gonna catch up on chat here a little bit. The values it's returning are all over the place. Yeah, that's basically what's in the Rock Band drums as well. Oh, is that right, Kami? I didn't realize that, but that makes total sense. BS Clara, I've heard silicone wires are really, really nice for things like this. Yeah, for sure. James, I have it taped to the block of wood to the side. When I move my hand off my desk, the values are changing. I'm not even touching the block of wood. Really? Is that sensitive? Have you tried a few different samples out of that pack you got? And Grogard, I order stuff from AliExpress if someone in the States doesn't have what I need. Yeah, and there was a part of me that thought with that BOM for the Snap-on Air PCB, I was like, well, maybe I should just like order it all from DigiKey. But I didn't want to spend like an entire day on DigiKey recreating this guy's BOM. So I just took the lazy approach. And the cheap approach, but everything came. All right. So we got this flashed. I think the flash worked. Let me go and make absolutely certain that the gateway is running the right version of firmware that I want. In fact, I might as well just pull it up in the console so I can make sure the flashing happens. Because that would be just like me to spend the rest of the stream beating my head against this and for everything to actually be working, except for the flash actually didn't take first time. So the last handshake was at 117. It may have meant the flash didn't work. Device OS is unknown? Alright, well let's try this again then. Cloud Flash. You know, I could be like super lazy too and be like, do a particle publish every time I do a serial print. Why don't I use my snippets? Not showing up, particle publish. I think my computer is begging for a reboot. I'm not seeing any change on my device. I don't know if y'all are seeing anything. I'm getting a message that the flash is happening. BS Claro. Oh, BS Claro, you me too. I suck at getting up too. I try to get up early, but yeah. James, I'm trying to make my bedroom a device-free space. It's good for the mental setup of the bedroom and healthy sleep. So I want an alarm clock that wakes me up with a relaxing tone rather than a nasty beep. James, I love that. So I stopped putting my phone in my bedroom a couple of months ago, and I got back on the Apple Watch recently. I've been a Fitbit user for like 7-8 years, and I finally took the plunge back on the Apple Watch, and I started using an app called Auto Sleep. And Auto Sleep, you can actually set your wake up time, and it will, within 30 minutes of your wake up time early, if you're in a light state of sleep, it'll actually use the haptic sensor to start just tapping you. So it will actually start just like lightly tapping you on the wrist, and that most days wakes me up without having any beeping on the alarm or anything like that, which is pretty sweet. I really, really like that. And James, this is pretty sweet. You want our alarm clock to also do breathing and meditation exercise. Man, that's awesome. That's really cool. And yeah, the Oura Ring. I wanted to look into that. It's funny, VS Claro. I like the Silicon Valley reference. That's funny. Use the Oura Ring for sleep. I really like the Oura Ring. It's so... I don't want to drop $200 on it. Especially after just dropping more than that on the Apple Watch. Yeah, Auto Sleep has been really cool. I've enjoyed it a lot. Okay, so this kind of concerns me that my Argon last handshake was a while ago. You got it on a Black Friday deal. Was it significantly cheaper than retail? Because that would have been great, if so. BS Claro, good question. What kind of tech does the Oura use? Because it's tiny. Has anyone done a teardown on like what sort of processor is in there and everything? Because I would love to see that. Do you know, James? I'm gonna put this into safe mode just to see if that will help me. And then failing that, I'm going to go ahead and do a local flash just so that I can make sure I get the right version of the device OS firmware on there. Alright, so it's in safe mode now, so I should still be able to do a cloud flash. But there may be something that's happening on there right now that's blocking it. Sometimes when I pull these devices off the stack, I forget that there was firmware on there running that completely disconnected it. Like I was running it in offline mode or something along those lines. And so that can happen at times. Okay, there we go. So I got the message that it was in safe mode, but it's not receiving. What the heck? Hey, Robert Tables, welcome back. Heck, that's where we are right now. I'm just trying to make sure this Argon is actually working. James, like $80 off, that's a big deal. I need to actually look up, let me see. Okay, I'm gonna make a note for myself in the stream notes. Because BS Claro, that's a really awesome question. See if I can find a teardown for the Oura Ring. Or if y'all want to look for one and you find it, throw it in chat. So the thing that concerns me here is it says the device OS is unknown. So I've got this thing. This may be another one of those devices that I inadvertently bricked. So I'm bringing it over here to my desk, and I'm gonna actually local flash it. So I'm gonna put it so it's off screen for a moment while I do this. Wrong window. Okay, so, and I'm going to do local flash application and device OS. So this is going to take a few minutes. While this is happening, let's go work on the Python side of this. That's a valid concern, B.S. Claro. Although, to be frank, I mean, the same concern would be true over the Apple Watch, right? Oh, sweet. Robert Taylor, did you find something? What am I looking at? I'm just looking at a bunch of different numbers. Oh, okay, here we go. Oh, that's a tiny little LiPo battery. 40 milliamps. That's a small little LiPo. Okay. Dang. Scrolling. Show me the ICs. So those are LEDs. I see resistor. Okay. Way down. Yeah, I see it. I wanted close-ups of the ICs. That's all right. I'll have to look through this later because this is pretty cool. But I want close-ups of what's right here. Because my guess, and this is a complete wild guess, but this right here is probably a Nordic chip, like an NRF 52. No, maybe the 52s don't get that small. But or actually maybe this one. That's nuts though. It's very cool. The communication is pretty slow. They're not constantly talking. I wouldn't imagine so. And yeah, B.S. Claro, for sure. Definitely the same concern with Apple. Did my... Oh, stupid pretzel rocks. Hold on. Oh. All right. I guess just delay on the sound, huh? And that's the first gen. James, what are you wearing the second gen? So does yours have this little like, I mean, I'm assuming that this is this size here in the front or the back because of all this. Enhance. That's what I need, .commie. I mean, I'm gonna click on these, it's not really gonna do anything. And the stats aren't real time, but it's Bluetooth, right? Is it a BLE device? Do you get stats primarily through your phone? Through a connection to your phone? It doesn't have a Wi-Fi chip in it, does it? Because if it did, the battery life would be shit. Second gen, much smaller. I hear Apple are working on ways to surface monitor blood glucose. Boy, that would be crazy. James, it's BLE, so you sync it a few times a day. I only do it once in the morning. And then how do you, is it, does it use wireless charging? Surely, right? There's not like a port in there. And does it come with a wireless charger, or does it come with like a contact charger that's on the inside of the ring? I'm fascinated by this thing. I'm not gonna, I mean, I've looked at this before. We've looked at this. Battery life lasts about a week. So, and I'll tell you, here's my TED talk on battery wearable devices. This is still the thing that ticks me off about the Apple Watch. And the reason why it took me so long is I have to be very strategic, and I'm one of those like insane, like life tracker kind of people. Like I love capturing stats about all the things that I'm a little obsessive about it. Like it's a way that my addictive personality manifests in what could be interpreted as unhealthy ways, although I try to hack that in a healthy direction for me. I hate putting this thing on the charger. I use it for sleep, like I mentioned earlier, because I use auto sleep to actually help me wake up without an alarm. So I can't charge it at night, so I have to have strategic times to charge it during the day. And if I'm sitting here at my desk, I don't sit still. Like I get up a lot during the day. And I don't, anyway, so I'm complaining about nothing. But it annoys me that the Apple Watch cannot last for a day the way that I use it. I used Fitbits for years, and I could get a Fitbit. Even the GPS Fitbits, I could get 4 or 5 days between charges. And I much preferred that over having to charge every single day. It's a put off, for sure. But I don't regret making the change because there's a lot on here that I'm really happy. I'm happy that I made the move for sure. It's a contact charger, but the pads aren't exposed. Interesting. Okay. Frackberg, Wear OS you can get 2 days out of. It's not a lot better, but I will give Samsung and Android credit there. And because it's Wear OS, I'm assuming that it's wireless charging as well, right? It's not a lot better, but 2 days is 100% better. Like I'll take it. I would take it if I could get it. Okay, so let me take a. I don't want to buy the ring. I just want to like see it. Okay, James. So this is, I get you. These are the new ones, right? Yeah, $299 to $999. Balance versus heritage. That seems to be like a very artificial choice. I mean, I see the difference. Black. The matte black. The stealth black is out. $400. And then it's cool that they can send you a sizing kit. How Aura works. You've totally derailed me, James. But it's okay, don't worry about it. You didn't do it. I've done this to myself. Okay. Okay. Go inside the Aura ring. Y'all want to watch a YouTube video? I'm not getting any sound. Don't tell me that's all I get. Are you kidding me? Okay, well that wasn't helpful at all. I gotta stop. I have to walk away right now. I'm gonna close this. It's not metal. Oh, that's interesting. Okay. Robert Tables, I'm watching a live stream video of a YouTube video. Yoda. Well, hey, let's get even crazier. Why don't we go to your... why don't we go to Michael Jolly's stream from yesterday and watch that? So we have a live stream video watching a replay of Michael Jolly's live stream video from yesterday. So those 3 dots, they're censoring how it charges. Oh, .commie, did I miss... Did you... Oh, I missed that video. Sorry. I missed that on chat. I'm in. I figured you would be, Michael Jolly. Oh, you DM'd me a picture of the pads? Cool. Thank you. Thank you very much. All right, let me get back to it. Or is this still going? This is still going. But I was going to go on to the Python side. So let's do that. In my Python library. No, not there. Not there. So emotion mesh. Local detector. I am going to... I'm going to get rid of these files. Because nobody wants to see those. Oh, James, you don't have to apologize. I willingly let myself get hijacked. Don't apologize at all. I know you're not trying to sell it. I willingly let myself get hijacked. It's not a Monday stream with Brandon if I actually do nothing but what I plan to do. That would be boring. Who wants that? And yeah, .com me. You have an affiliate link, James. Yeah, send us your affiliate link because, hey, if you're getting some affiliate cash from that $500 ring, we want to get you paid, brother. Because you totally should. That'd be awesome. All right, y'all. It is almost the top of the hour, and I'm still waiting on this to build. So before we start on the Python side, I mean, this is doing its thing, which is great. But now would be a good time to take a bio break, stretch break. Everybody, do those things. I'll be right back. Again, 2 minutes. No affiliate link. It's a bummer. They don't know what they're missing out on. Okay. Let's get back to it, and I am going to... I have a file here called uart.py that's at the root of my Motion Mesh server. So I was messing with this a couple of weeks ago. This piece isn't doing anything right now. But I'm going to change this to what Grogard had mentioned earlier. So let me scroll back up in chat. This is good golly, that was like a long time ago. I'm stealing your code, Grogard. You copied it in chat, so it's mine now. So I'm importing, yeah, from periphery. So I'm not using GPIO. So from periphery, import serial. And this should work. All right, I'm gonna need a setup. Sorry. So we'll do uart serial.serial dev tty s1 baud rate 11.5200 timeout 100 milliseconds. Right, and then with the serial object, I should be able. There you go. I should be able to do a serial read with the buffer. How do I know if bits, if bytes are available at any point? Does this just do this every 500 second? Grogard, I would just verify that the layout is the same. Yeah, fair enough. For sure. And that's a valid point. So pinout that also includes the SoC pin name. Let me check the dev board data sheet, and maybe this will actually give me a physical. What just happened? Okay. You know, Grogard, I gotta give me something here that gives me the right orientation. Oh, pinout schematic. That's not useful. I mean, it's great. Yeah, because you were using Pi serial and this is periphery, but yeah, I'll go look at the docs here in a sec. Back of the docs on that. Oh my gosh. Okay, this is wonderful. Wonderful data sheet. It's like every other data sheet. So unfortunately, the pins, the 40-pin header is not color-coded. So I have no way. Oh, there it says pin 1. How did... Ugh. Sometimes when you're moving so fast that you miss the details, like all the time, y'all. All the time. But Grogard, I appreciate you saying that because I have struggled with, yeah. I've gotten messed up on things like that in the past for sure. Always good to double check. Yeah, I'm assuming pin 1, 2, 3, 4, 5, 6, 7, 8, 8, and 10. Okay. So it's not serial.serial, it's just serial. I don't want to call it UART, it's just serial. That's fine. You are a pro now, Michael Jolly. You spent a good amount of time on this the other day. Yesterday. That was just yesterday. You know what you're doing? Absolutely. It probably does use Pi serial underneath the covers, Grogard. Yeah, I wouldn't be surprised. All right, so read 128 bytes. I mean, I'm not sending that many bytes, but whatever. Up to 128. And then, do I need to close? No. How do I clean that up after the fact? All right. Oh, hey, my Argon is back. This is good timing. Let me actually see if I got... Am I back on? Am I online? I am online. Am I running a good version of the device OS firmware? Because if not, it's going to be time to get Argon number 3 out. 110. All right. Good stuff. Oh, I got it. All right. So back over here. White cable. Yeah. Again, this is another one of those things I have to be absolutely certain of. Where did I get all messed up on this connected GPIO? Is this different than it was like 20 minutes ago? Hey, actually, look at this. There's actually now patents. Okay. So did they change the docs since I loaded this page? Which may have been several days ago. But this actually has the sysfs paths now. That's great. Okay, cool. UART1 is dev TTY MXC0. That is not at all what we were looking for. Dev TTY MXC0. There you go. I swear, y'all, these docs were updated like just now. This is what happens when you're on the bleeding edge using dev kits that are in alpha version. So dev TTY MXC0. So let's see, I'm gonna make a note of that. That is UART1. That's crazy. I love that. That doc update just saved us a lot of time. Check the last two variables for baud rate and timeout, Growguard. James, so this will be my first project actually soldering a bunch of components together. Can you recommend the type of wire to use? I can. Let me go into my Amazon history and I'll send a link here. Just a second. I will warn you, I am going to make a recommendation for leaded solder. I don't use lead-free solder. So I recommend just buying a fume extractor as well. I do not like lead-free solder. So if you prefer lead-free solder, I am not your man to make a recommendation. But this is the stuff that I use. Kester rosin core solder. There you go. And that is not an affiliate link. Just FYI. So I'm not getting paid to make that recommendation to you. That's a big spool too. Like that spool, I've had that spool for about a year and year and a half, and I've barely made a dent in it. Ah, cool, Frackberg. I'm not alone. Good. Yeah. Growguard, they look different in the docs. Okay, cool. Let me look. Dev path, baud rate, data bits. Oh yeah, there's no timeout. There's a baud rate, not a timeout. So I'll just use baud rate 11520. Oh, I don't need to make a name parameter out of it. Okay. Oh yeah, James, you asked about wire, not solder. How about, that is so nice of you that you actually said thanks and I didn't answer your question. I'm sorry, man. It's just been one of those weeks for me so far. Yeah, I did not answer your question and yet you still said thank you. I appreciate you, James. You totally could have said, no, idiot. That's not the question I asked. Let me find the wire that I use. I'm fairly certain. It's been a while since I bought wire because I use the same stuff as well. But let me go back a bit in my order history because the stuff that I have. Yeah, see, there you go. Hey, doofus, I want wire. No, this isn't Twitter or YouTube Live, right? Grogard, I use some thin enamel copper wire for badge work. Oh yeah, you gotta have some good bodge wire. I'm almost there, James. I'm looking back. I'm taking this trip down memory lane of all the stuff I've spent money on Amazon. Good God. No, that's too far back. Hey y'all, I bought my first Kindle on June 24th of 2008. Okay, Robert Tables, can you find that? Because that's exactly what I was looking for. I have that exact same wire. That 22 gauge solid core wire in 5 different colors in a cardboard box with the little feeders out the back. It's exactly what I have. Can you track that down? Because I think that's what you need, James. I love that wire. That's a good one. It's really good. All right. Serial dev TTY 1152. All right, well, why not? And I'm gonna go back to the docs to get this reconnected. 8 and 10. So 8 is TX on the coral, so it means you go into RX here. 10 is RX on the coral, so it means you go into TX on the RX. Right. So we should be good to go now. Let me verify that my particle project is actually sending. All right, let me restart this. It's going to configure serial 1. Frackberg tend to prefer stranded wire for soldering. I hear you. It's totally personal preference thing. Yeah. I do like stranded wire as well. Solid core wire, I get. There's certain kinds of things I really like it for sure. What's going on? I'm going to get serial 1 not available. Because I want to make sure that these serial events are actually sending, and they're not. Not right now, 1Password. Thanks. You know, Frank, that's a really good point. It is easier to get cold joints on solid wire. If you use thicker solid, I mean, thin solid wire can happen too. But you're right. You can definitely get cold solder joints much more easily on solid wire. And I have. That's annoying. All right, I'm just going to take out the. Let me flash this. To cloud flash it now. I know, Frankberg, I appreciate that. That's good. I mean, we all have varying levels of experience with this, so it's good to hear what's worked with other people. And no, it's great. Great advice. I'm noticing that my filter on the green screen is not looking great today. I know y'all don't care, but it's weird. All right, so the serial sent is happening now. Cool. Great. Wonderful. Now let's run this on the Python side and see if everything blows up or if something actually works. And as I usually say, if this works the first time, I'm gonna be shocked. I'm gonna be shocked and awed if this actually will show me something. So I'm gonna go to my zipmol and it's clear. And let's see, where are we at? In UART, it's under local detector. So Python free local detector UART. And I just need to rename that. Permission denied. So what do I need to do? Let's see. Yes, that makes sense. That my current device doesn't have the ability. I mean, I guess I just run this sudo, which is not what I want to do long term, but is that all it is? Yeah, give the device read access. Python 3 local detector UART. While true. Oh, I'm trying to write like CircuitPython here. How do you just wait inside of a regular old Python script? I mean, I suppose I could. Usermon AG dial out my username, Grogard. I need to look that up. Oh, okay, yeah, I got you. Yeah, I know I can do a sleep. Yeah, I mean, so like I know what I could do is just like import time. Right, import time, and then what I could do is try to do like a fine. Sleep, and then like 5 seconds or whatever. But I just want to do like a while loop. Oh, no. I was wrong. Yeah, wow, true. I actually have to have my booleans properly cased because it's Python. Yeah. Read 0 bytes. It's sending them. Well, poop. Yeah, all right. Let me go back to the docs. Dev TTY MXC0. Ah, Sir Dave, thank you so much. I was actually just about to ask myself, and it sounded dumb in my head, but apparently it was not, that I need to have a common ground between the boards. I think you're right, Sir Dave. Thank you so much. A happy Monday to you. I totally... Thank you for being the voice of reason here. Because I totally forgot about that. I'm claiming that I thought it, but you said it out loud. You still get the credit. You get all the credit, Sir Dave. And hello to you. Okay, where's the ground? 6. Perfect. There's a ground on 6. This heat sink's getting a little warm, a little toasty. All right. Okay, offline. Let's rerun the script. Sir Dave, I am good for making common mistakes. Well, it sent that and then the script stopped. That can't be good. Unlurk. I need to add that command, Michael Jolly. Well, I feel like that's at least closer, Sir Dave. It's still not working. Okay. So what's happening is something seems, yeah, it's new. You're right, sir. Exactly. Like something different is happening. So I suppose that's a positive. The question is what I'm doing wrong. All right, my baud rate is the same, right? 11.5200. Sending a single character, and I'm using serial 1. Let me, you know what? Let me make sure. Let me make sure I'm using the right serial port. I'm using the right UART here on the Argon. Because maybe this is an issue with me forgetting the way that TXRX work on the Argon. I do believe that, oh man. Hold on, we'll get there. Zoom, 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 zoom. That's UART1. UART1 TXRX. That's serial 1. Which should mean that this code is correct. However, let's maybe well, that shouldn't matter. Is it possible that I've set the baud rate too high? Is it possible? Is it possible? I mean, I'm sending a single character. So do I really care that I need to be at 11.5200? Probably not. So I'm going to bump this down to 96. And yeah, I do, Sir Dave. I have both of those things available, not here close to me on the desk. So failing this, like if we don't get this fixed on the stream, then I'll go over to the scope off stream and try to figure it out. 9600. So I'm going to bump down to 9600. And then once that comes back online, I'm going to rerun the script. Hey! We got 3 bytes. At 9600, we got 3 bytes. And it failed after the first time. The Michael Jolly, we keep the stream going until the work is done. We're hardcore. Now that was 4 bytes. Okay. Not here. I wish I could do that, Michael Jolly. I have a phone call at 3 p.m. Central. I have to like get on the phone to have a meeting with the people that I work with. Otherwise, I would. And 4 bytes and 3. Nailed it. Is that nailed it? I like that, Sir Dave. Thank you. Grogart, what would you do? Small sleep. Where do you think I should add that? Thank you for that, Michael Jolly. I appreciate it. Didn't it feel so good when things work? It feels so good when things work. Would you do the sleep after I'm out of bits or I'd cheer? Oh, no worries. Would you do a sleep of just like at the end of the loop? What do you think? Like 100 milliseconds? The time.sleep? Or is it capital T time? It's not capital T time, is it? It's not time.sleep, is it? Oh my gosh. What's wrong with me? No, it is. Ah, James, thanks so much for the cheer. That's awesome. Appreciate that cheer. That's very kind of you. 50 bits. I'm going to add that into my notes. Where are my notes? That's right. All right. But it froze on me again, Grogard. Oh, Sir Dave, is that right? Use serial available to check the character. Oh, okay, cool. So there's something on periphery that I wasn't aware of. So serial, we'll check it API. Or is it a poll? Serial poll. Poll for data available from reading. Timeout can be positive. Returns true if data is available for reading from the serial port. False if not. Since this is on the Python side, right? Serial available I would use on the C side, C++ side. So like, if serial dot poll timeout duration in seconds. I don't know. Let's just do none. Yeah, Sir Dave. It's just that serial poll. Oh, right, Grogard, you're right. Import, yeah, from time. Still getting used to the Python syntax. Import sleep. Thank you. Would you still do the sleep, Grogard, if I'm actually polling? I mean, I don't know, give it a try. So if serial poll, read from the buffer, shouldn't need that? Okay. And we'll do no timeout and see what happens. See what happens. Oh, dang it. What? Where's the error? Unsupported for none type and int. In line 10. Oh, it doesn't like what I did with the poll. Really? Alright, fine. So let's do timeout of like half a second. Or 1 second. Okay. Now we're getting somewhere. Ah, I see, yeah. I see your comment now, Grogard. Great minds. 1 byte. Those are just new line characters though, right? It probably just wants something there. Yeah, you're right. I suppose oh yeah, you have to set something. Int, float, or none. But I'm wondering, is this garbage data that's coming in? Let me change this. Okay, so now that we think we have a good connection here, let me actually send... let me send something more substantial. Right, and right. Let me just send a 1. Not the character, but a 1. Because be brave, send hello world. I don't know, Sir Dave. That may get me in serious trouble. I could. I mean... Okay, device is coming back online. Oh no, BS Claro, that's terrible. Fix it in 45 minutes. Well, good luck. Good luck. I hope that goes well for you. Sort of like Serial B, Hello World. Oh, I got you. Okay. You know, the implicit cast. Why not? Why not? Let's do it. Because I don't feel like I'm getting valid... So if I... Yeah, but it's not going to work in... No, but if I do that... No, it'll work. I think it'll actually work like this. No clue how to fix it. Random prod server running out of heap space. That stinks. Oh my gosh, BS Clara, I'm so sorry. This is not cool for a Monday. Grogard, I think that the Particle Device OS will handle this fine. But let's find out. Oh, what? I did not like that. Okay, now it seems to be connected. All right, so now I got 12 bytes. And then 1 byte. Sending ASCII should be okay. So then my question is, all right, so I'm getting the bytes and this is it. So here's another byte. Good luck to you, BS Claro. So sorry. I hope that goes well. I'll catch you next time. All right, and then a couple of new line characters. So I suppose my question would be then, how do I reconstruct this into something on the Python side? Where's my Python? How do I then reconstruct this into something? So serial gives me a buffer, right? Read gives me a number of bytes. So what is C? I'm just gonna do Python bytes to string. I'm not the first person that's asked this question. Oh, well, yeah. I suppose stir with just UTF-8. Okay, well. Let me try that. Let's try that. Let's get ourselves a little bit more sophisticated here. And we will clear. I'm going to reset the argon. I'm wondering, well, I'll ask you guys about what I need to do for cleanup, because I feel like, do I need to be doing something periodically to shut down the serial port? Nada. Nothing so far. There's something about this that feels inexact and incorrect. What in the world is that? Yeah. Yeah, that's not right at all. All right. I'm going to go back onto the particle side, and where am I? Not going to send to hello world. I'm going to go back to just sending this character 1. Flash that again. I mean, there's something happening. We have accomplished a goal in the sense that I am seeing cause and effect. It would seem that when serial data is being sent from the Argon to the Coral, that the Coral is receiving it. So that's great. Oh, you think I need $S for strings in Python? Okay. This is totally be just a Python thing here. Well, I've got that. Underscore. Why did I do that? Okay. Oh, that's why I was doing that. I think that's what I'm doing, Grogard. Why does that fail when I... Is that failing because I'm not cleaning this up well and properly? Read 1 byte of nothing. So now I'm sending along a single character. And it is supposedly reading that character, but not able to successfully output that character? Does it matter that it's a 1? Should I send the letter A? I mean, should that matter? Add the printing of the value again. I've still got that in here. On the Python side, I still have the printing of the value. It's just here. So there's something on the cleanup side that I need to be doing, I think. That's right. So reset the argon, and I changed the character to just be an A. So when this comes on the console side, it should start sending serial messages again. Just sent one. And the Coral has not. Hey, an A! Look at that. So that's pretty cool. We're actually getting, so it's an A, it's fine. So I was doing something when I was trying to send the number that was just not working. It's probably my lack of understanding of how Python serial works. So I just need to do my homework on that. However, it's only happening like the first time. Is there like, you know what? I wonder if there's like a flush. Let me look at the API here. Or is this even like a parity thing or stop bits I need to deal with? Well, Sir Dave, that's what I thought. It should have worked for the 1. So maybe the issue is that I'm not using... Here, let me see. What's the default... on flow control on the particle side, because it's probably an issue, a misconfiguration between flow control on the particle side, stop bits and what have you, and what Python is expecting by default. So when using hardware serial channels, the configuration of the serial channel may also specify the number of data bits, stop bits, parity, etc. The default is serial 8 and 1, 8 data bits, no parity, and 1 stop bit, and does not need to be specified. Okay, so we want the same thing, 8 data bits, no parity, 1 stop bit on the Coral side. So I need to, the right thing to do here is to specify this, because data bits are 8. I don't know if this is default or not. So let's assume. Let's assume that it's not. 8 data bits, no parity, 1 stop bit. Okay. Which is everything here. And we'll leave these. So I'm just going to set those. 8 data bits, no parity, 1 stop bit. I get tired of hearing that yet? Reset the argon. It's so weird. There's something here is not right. I mean, Dare develops 8N1 9600 every Cisco device everywhere. Very true. Hey, happy Monday to you. I love that. That's great. So now I'm wondering if X on, X off. Well, so I don't know if these are defaults, but let me mess with the flow control, the hardware, software flow control stuff and see if that actually helps. What's the way to capture a keyboard interrupt in Python? Because I think that would be a good time. Keyboard interrupt. That'd be a good point. I think I need to close the serial monitor out when that's happening. Yeah, stupid Python tricks. I like that. I'm stupid. I could use that. That's not helping. Handling Control C. Keyboard interrupt signal. Handling Control C cleanly in Python. I think I accidentally clicked on the wrong doc. Oh, but this is what I want. SIGINT. All right, I'm going to sidebar for a second because I feel like it's just not a good idea for me to keep on killing this and not doing anything. So import signal. Great. And then fine. And here, wait, you need to be up here. Sorry, I need to get back to serial.close. Okay, there. I feel so much better about that now. And now I have to actually register it. Okay. So then what I should be able to do now is next time. Is kill this. Is that good, right? Yeah. Or was there an error in my interrupt? Line 17. Or did it work? Oh, maybe it actually worked. Okay, fine. So I added software flow control on that, and that didn't make any difference. Let me restart the device, because I'm getting sort of like weird different results, and unfortunately, I got a meeting in 8 minutes, which means I'm gonna have to end this stream here in the next 2 or 3. With this unresolved. Not unresolved. I mean, the good news is the UART connection is working. There actually is a connection. Thank you so much, Sir Dave and GrowGuard, for your help on that. We are sending data between. I'm just getting inconsistent results on reading it on the Python side. And that's totally because of my Python noobness. So I will fix that. And that's something I'll work on in the next couple of days. So we'll have that working by next stream. Let me review. So we got the UART communication configured between the Coral and the Argon. We got that piece working. I know, Sir Dave, I know you would have cracked out but I don't have a portable one that I can bring over here. I gotta like, it's behind me on my other desk. And I gotta like move this over there. I should, maybe for next week, I'll get the logic analyzer over and we can do some of this live, because that might be kind of fun. But I do need to go do that over there where it lives on my desk. But thank y'all. So I'm going to get the serial part figured out. And then what we'll do next week is we'll start working on connecting up the arcade buttons and then screen capture, cloud detection, all that kind of stuff. So we'll get this whole thing hopefully wired together by next week, on the stream next Monday, to where you can actually hit the buttons to trigger a screen capture and to start to do some detection between the devices, which would be kind of cool. So in the meantime, I am going to, I'm gonna find somebody to raid here. So if y'all have any suggestions, anybody that's in the live streamers group that's streaming right now, please let me know and I'll take a look. Who do I got? Who do I got? But thank y'all so much for coming and hanging out today. I know that it was a varied stream. We were kind of all over the place doing different things, but this was fun for me. We got to do a little bit of recapping of Python stuff. Y'all taught me some Python today, so that's always kind of fun. I'm opening up the live coders. What live coders are on? Let's see who's on. Okay, I've rated source. I have rated Codephobia before, but I don't think I've rated SourceScoop before. So let me go to their channel real quick. Let me see what SourceScoop's working on today. And thanks, James. Hope you have a good week as well. I am sure that you and I will be talking on Twitch and whatnot over the next couple of days. Yeah, there's a lot of good stuff, Michael Jolly. And I'm looking forward to your stream tomorrow. I will be there. Oh, there you go. PWA with Vue and Arduino. All right, so let's go raid SourceScoop. We're going to do that. Y'all hang out for a minute. Please do. And if you got to go, that's fine. I'm going to have to go to a meeting, but please do hang on long enough to raid SourceScoop to support other fellow streamers. Want to go say hi to them and see what they're up to. So please hang out for the raid for just a moment. Say hi. Thank y'all so much for coming and hanging out today. This was a blast. I had a good time. Even if we don't get a ton done, I still have a good time. I will fix these issues here and we'll learn more together next week. So y'all have a great rest of your week and I will talk to you very soon. Bye.